Good morning, everyone. Today we continue our lesson on the autonomic nervous system. Okay, we're going to learn about the parasympathetic and sympathetic, how they affect on our nervous system, as well as the effects on curare and cocaine on the neuromuscular junction. So, autonomic nervous system is a part of the nervous system that controls and regulates the internal organs without any conscious recognition or effort by the organism. And then this autonomic nervous system contains only the motor nerves or motor neurons. Okay. Autonomic nervous system regulates involuntary activities of glands, cardiac and smooth muscles, such as sweating, heartbeat, and peristalsis in the gut. So you don't tell me that you can control the peristalsis in your gut. You can't, as well as your heartbeat, okay, and your sweating. And then this autonomic nervous system, okay, is regulated by the medulla and hypothalamus, and then divided into parasympathetic and sympathetic, okay, nervous system that work antagonistically. Antagonistically means berselang-seli. Okay, one acts as a protagonist, okay, at the same time the other one will act as an antagonist. Okay, so this is a diagram that shows you how the sympathetic nervous system, okay, differ with the parasympathetic nervous system. Okay, so we have on the left side here that shows us on the sympathetic nervous system, while on the right side here shows us the parasympathetic nervous system. Okay, so the first differences, all right. In terms of organization, okay, the sympathetic nervous system consists only spinal nerves. Okay, you can see here, consists only spinal nerves. This is the brain and this is the spinal cord. And any extension from the spinal cord, okay, is known as the spinal nerves, while extensions from the brain is known as the cranial nerves. Okay. So you can see here, the sympathetic nervous system consists of only these spinal nerves, while the organization of the parasympathetic nervous system consists branches of cranial nerves, number 3, 7, okay, then 9 and 10, okay, as well as the branches of sciatic spinal nerves. Okay, so these nerves, okay, makes up the parasympathetic nervous system. Next, let's take a look at the nerve's length. Okay, now for the sympathetic nervous system, okay, you can see that they have, or it has, okay, short preganglionic nerves. Okay, you can see this. This is the ganglion. Okay, you can see this preganglionic nerve, which is shorter compared with this postganglionic nerves, which is longer. That's why they are being labeled as dotted lines. Okay, contradicted with the parasympathetic nervous system, where it has longer or long preganglionic nerves, okay, but shorter or short postganglionic nerves. Okay. Now, the location of the ganglion. Okay, so first things first, before that, I forgot to mention ganglion. Okay, what are these ganglions? Okay, these ganglions, they are cell bodies of neurons, okay, that are grouped together in masses outside the central nervous system. Obviously, this is the central nervous system, and this will be outside the central nervous system. So, outside the central nervous system, where this ganglion can be found, right? Okay, now, For the sympathetic nervous system, their ganglion locations can be found near the spinal cord. Okay, you see, near the spinal cord, but far from the effectors. While for the parasympathetic nervous system, their ganglion can be found, okay, far from the spinal cord, but nearer to the effector. And then in terms of number of nerves from each ganglion, okay, from each ganglion, you can see this ganglion here, okay, and then in terms of the number of nerves, for the sympathetic nervous system, it has more postganglionic nerves. You can see here, it has more postganglionic nerves compared with the parasympathetic nervous system, where it has less postganglionic nerves. Okay, now areas affected. Now for the sympathetic nervous system, okay, it is distributed. The distributive effect, okay, is along both sides of the spinal cord. While for the parasympathetic nervous system, okay, the areas affected is localized. It has localized effect in visceral organs. You can see these are all the visceral organs, right? Localized effects in visceral organs. So meaning to say, this parasympathetic nervous system has effects only on the visceral organs mainly, right? Okay, now these are other differences. Okay, let's go one by one. Now, okay, neurotransmitter in the postganglionic nerves. Okay, for sympathetic system, okay, we have norepinephrine. Okay, while for parasympathetic system, we have acetylcholine. Okay, type of neurotransmitter that is available, okay, in the postganglionic nerves. Now, effects of sympathetic system on iris, it dilates the pupil, okay, but for parasympathetic system, it constricts the pupil. Okay, sympathetic system has no effect on tear glands, while parasympathetic system stimulates tear secretion. Okay, sympathetic system inhibits secretion of saliva, whereas parasympathetic system stimulates secretion of saliva. Sympathetic system increases heartbeat, whereas parasympathetic system decreases heartbeat. Sympathetic system dilates bronchioles, whereas parasympathetic system constricts the bronchiole. Okay, sympathetic system increases breathing rate, whereas parasympathetic system decreases the breathing rate. Sympathetic system decreases peristalsis, whereas parasympathetic system increases peristalsis. Okay, sympathetic system inhibits secretion of digestive juices, whereas parasympathetic system stimulates secretion of digestive juices. Sympathetic system contracts anal sphincter, whereas parasympathetic system relaxes the anal sphincter. Okay, sympathetic system constricts the visceral arterioles, whereas parasympathetic system dilates the visceral arterioles. Sympathetic system increases blood flow to the brain and muscle, whereas parasympathetic system decreases the blood flow to the brain and muscle. Sympathetic system increases blood pressure, whereas parasympathetic system decreases the blood pressure. Okay. Sympathetic system contract the spleen, okay, and this will cause less blood in spleen, whereas parasympathetic system has no effects on the spleen. Okay, and then sympathetic system, okay, causes the hair angles to increases. This is to retain body heat. Okay, whereas parasympathetic system has no effect on the hair angles. Sympathetic system, okay, constrict skin arterioles, whereas parasympathetic system dilates the skin arterioles. Okay, this in turn will cause, okay, sympathetic system, okay, increases sweating, okay, whereas parasympathetic system has no effect on the sweat glands. Okay, but sympathetic system effects on sweat glands is that it increases sweating. Sympathetic system, okay, decreases urine production, whereas parasympathetic system has no effects on the kidney. Okay, sympathetic system contracts the sphincter muscle in the bladder, whereas the parasympathetic system, okay, will inhibit sphincter muscle contraction in the bladder. Sympathetic system, okay, will stimulate ejaculation, okay, from the penis, whereas the parasympathetic system, okay, will stimulate erection from the penis. Okay, so class, there is a differences here between ejaculation and erection. Sympathetic system, okay, stimulates the adrenal glands to release adrenaline, okay, whereas parasympathetic system has no effect on the adrenal glands. And from all this, okay, conclusively, the main function of the sympathetic system we can summarize as to prepare the body for stress or flight, as well as for arousal. Okay, arousal. Whereas for sympathetic system, okay, its main function is to relax or calming, okay, or restore the body from stress. Okay, so that's about the sympathetic and parasympathetic nervous system, okay, and their examples. Now let's proceed with mechanisms of drug action on the nervous system. Okay, so for the STPM syllabus, okay, we focus on dopamine, right, as well as epinephrine and norepinephrine. So mechanisms of drug action on nervous system involves dopamine in the limbic system, right, and epinephrine and norepinephrine in the sympathetic nervous system. So when it comes to limbic system, okay, this mechanism of drug action involves dopamine. When it comes to the sympathetic nervous system, this mechanism of drug action, it involves the epinephrine and norepinephrine. Okay, now, so let's take a look at the action of this dopamine. Okay, now cocaine is one example of drugs, right? Cocaine affects the synapses of the limbic system. Okay, now limbic system is the pathway that produces pleasure in the brain. All right, so limbic system can be found inside our brain. Now this cocaine binds tightly to the dopamine transporter protein in the presynaptic membrane, causing accumulation of dopamine in the synaptic cleft. Cocaine prevents reuptake of dopamines by dopamine transporter. So you can see from this diagram here. Okay, this is a presynaptic axon that has the presynaptic membrane. Now, this cocaine, right, it binds tightly to this dopamine receptor. This cocaine, okay, binds tightly to the dopamine transporter in the presynaptic membrane. You can see this is a dopamine transporter, okay, and it's being bind by this cocaine. So when this cocaine bind with this dopamine transporter, what happens? The reuptake of this dopamine from the synaptic cleft is being prevented, halted, or stopped. By this dopamine here, okay, after it already binds with the dopamine receptor here on the postsynaptic membrane, okay, this dopamine will be recycled, okay, recycle or break down, and then it will be reuptake by this dopamine transporter. But what happens here is cocaine block this dopamine transporter. So reuptake of dopamine is being halted or stopped. Okay, so there is no reuptake of dopamine. So what happens to the concentration of dopamine in the synaptic cleft? It will increase. Okay, so before the dopamine concentration increase in the synaptic cleft, this dopamine will accumulate first. Okay, now in normal synapses, okay, dopamine binds to the dopamine transporter in the presynaptic membrane. So cocaine binds to dopamine transporter and reabsorption of dopamine is blocked. So dopamine stays and accumulated in the synaptic cleft. Dopamine receptors at the postsynaptic membrane are stimulated again and again. Okay, why or how does this dopamine receptor, okay, at this postsynaptic membrane is stimulated again and again? How? Yes, this dopamine receptor is stimulated again and again because of the accumulation of dopamine in the synaptic cleft. So this accumulation of dopamine, okay, will keep on stimulate, okay, action potential here on the postsynaptic membrane. How? By binding the dopamine receptor. Okay. Each time the dopamine bind with the dopamine receptor, what happens? There will be influx of sodium ions into the postsynaptic membrane. Okay, and then the influx of the sodium ions into the postsynaptic membrane, okay, will propagate the action potential. So we can say that action potential is being propagated or stimulated again and again. As new impulse arrives at the presynaptic membrane, more dopamines are exocytosized or released into the synaptic cleft, causing firing of impulse to the pleasure pathway more frequently. So what happens after that? The central nervous system, okay, class, please do not write CNS in your essay exam, okay, please write there central nervous system. So the central nervous system will adjust the limbic system by producing less dopamine receptor, okay, because this continuous firing of impulse is bad for your body. So your central nervous system will adjust, okay, will try to limit this frequent firing of impulse by producing less dopamine receptor. So with less dopamine receptors, less dopamine is being exocytosized or released by the presynaptic membrane. Okay, so the user needs the cocaine to maintain normal level of limbic activity. So the user becomes addicted to the cocaine. Okay, so now when this continuous firing of impulse in the postsynaptic membrane, okay, will cause the central nervous system to adjust the central nervous system, okay, by limiting or decrease the number of this dopamine receptor. Okay, now when we have less number of dopamine receptor, we will have less number of dopamine being released or exocytosized to the synaptic cleft. All right, now when that happens, okay, the user, okay, will need more cocaine. Why? So that more dopamine transporter can be blocked. This is to keep on, okay, to keep on the level, or to maintain the level of concentration of dopamine in the synaptic cleft at certain concentration, right? Why? To maintain the normal level of limbic activity for that drug user. Okay, now epinephrine and norepinephrine, how are they differ? Okay, so both are neurotransmitters, okay, that also serve as hormones and belong to a class of compounds known as catecholamines. Okay, as hormones, both influence different parts of our body and stimulate our central nervous system. Having too much or too little of either of them can have noticeable effects on our health. Chemically, epinephrine and norepinephrine are very similar. Epinephrine works on both alpha and beta receptors, while norepinephrine only works on alpha receptors. Okay, alpha receptors are only found in the arteries. Beta receptors are in the heart, lungs, and arteries of skeletal muscles. So it's this distinction that causes epinephrine and norepinephrine to have slightly different functions. Okay, so you can see here the cocaine abuses brain. Okay, how they are different. So you can see here on the third month, what happened here? Cocaine abuses brain has low frontal. Okay, you can see here, this is the frontal, low frontal metabolism, and this contribute to the loss of control. Okay, that's why these cocaine abusers, they can't control themselves. Okay, they're behaving like zombies. Okay, now the last one for today, mechanisms of action of curare on neuromuscular junction. And when it comes to neuromuscular junction, what is the type of the main type of neurotransmitters involved? Yes, it is acetylcholine. Okay, so whenever you see neuromuscular junction, first thing come in your head is the neurotransmitter, which is acetylcholine. When it comes to limbic system, the neurotransmitter that is mainly involved is the dopamine. Okay, so on this diagram here, you can see these are the acetylcholine receptors. Okay, so acetylcholine receptors will bind with acetylcholine. Okay, when this acetylcholine receptor binds with acetylcholine, what happens? Influx of sodium into the postsynaptic membrane will occurs, which in turn will propagate action potential. Alright. Now, curare, okay, however, will compete with acetylcholine, okay, on the acetylcholine binding sites on the acetylcholine receptor. So curare will bind to the acetylcholine binding site for acetylcholine. Okay, similar. Okay, so I think typo here. Right. So when curare bind, okay, with the acetylcholine receptor, what happens? This will block the formation of transmit of impulse to the muscle. Remember earlier I mentioned that this action of acetylcholine mainly involved in the neuromuscular junction. Okay, so this will when curare bind with the acetylcholine receptor, what happen? Propagation of impulse in the muscle or postsynaptic membrane or sarcolemma is being prevented or stopped. Okay, now the block transmission of impulse to the muscle will cause paralysis. Okay, what is paralysis? Paralysis, okay, is the loss of muscle function for one or more muscle group. So high concentration of curare will cause death, especially if paralysis, okay, in the muscle that control the breathing process. So that's it for today. Okay, so see you next lesson on hormones.